Hey Algebra One, how are we doing this week? I hope that we're doing great, okay? Staying inside, the weather is getting a little bit nicer out, a little bit warmer. Got some rain though, but maybe get out your rain boots and go for a walk. Why not? Okay? This is our fifth week of online learning, which has been going great so far, okay? We're a lot more comfortable with it, and we're gonna keep moving forward, okay? This week, we're going on to still working with quadratics, but it's a different way to factor. It's a factoring method called completing the square. So, without further ado, let's learn how to do that.
All right, algebra. So far, we've talked about three different ways to solve quadratics. The first way was we solved it by square rooting. Second way was we solved them by factoring. And then the third way was solving by using the quadratic formula. This week, we are adding our fourth and final way to try to solve or factor quadratics, and it's actually factoring by completing the square, is what this is actually called. Now, there's actually a method of completing the square using these algebra tiles, which unfortunately we won't use today, but maybe I'll throw up a video that actually show you how you are quote unquote completing the square. It's kind of cool, and it definitely kind of brings together the name and the actual steps and processes. But let's start by using or by going through these steps and processes. So the first thing is that we need to make sure that our leading coefficient is equal to 1. If it's not equal to 1, then we might have to do some division or multiplying or something else like that, okay? I need to isolate my x squared plus bx. So this ax squared plus bx part on one side of the equation and the constant term on the other side of the equation. So I might need to add or subtract my constant, my c, over to the other side. And then I complete the square. What that means is that I have to take my middle b term, divide it by 2, and then square that number. And I have to add that to each side of the equation. Okay? Because whatever I do to one side, I have to do the other. I have to factor the perfect square trinomial, which is going to look like x plus the b over 2 squared. Whoops, not squared. Squared. We'll see that. And then I square root each side and isolate x. Okay? So let me erase this and make it a little bit smaller, so that way it's a little bit easier to read. So it'll be like x plus the b over 2 squared. So this is what we're going to be doing, and we're going to try this out with a couple of examples. I have 4 different examples for us to look at. Okay, so let's jump into it. Our first example is x squared plus 6x minus 12 equals 0. So I see that my leading term, has a coefficient of 1. So that means I need to move my 12 over to the other side, my constant. So plus 12 on both sides. And I get x squared plus 6x equals 12. Now I need to do the b over 2 and square it. So that'll be 6 divided by 2 squared, which is 3 squared, which is equal to 9. So now I need to add 9 on both sides. So we're going to have x squared plus 6x plus 9 equals 12 plus 9. And I know that this factors down to become x plus 3 squared equals 21. So let me jump to the next slide really quick, and I know I'm going quickly, so feel free to pause this and write this down. Okay. Next slide, so I'm going to have x plus 3. Well, that does not look like a 3 whatsoever. I have x plus 3 squared equals 21. What I have to do now is I have to square root both sides of this equation, so that way I can solve for x. So I have x plus 3 equals plus or minus the square root of 21. So now in order to get x by itself, I need to subtract by 3 on both sides. And my answer is x equals negative 3 plus or minus the square root of 21, whatever that is. And that's it. In this case, I don't really need to know what the square root of 21 is. I'm just going to go ahead and say it's plus or minus whatever that value is. I'm not going to make it harder if I don't have to. Okay? So let's try another example. B, x squared minus 12x plus 4 equals 9. So this one's a little bit different in the sense that I have a constant also on the other side, but that's not really going to switch up what I'm doing anyways. I still see that my leading term is 1, so I can go ahead and move my constant over to the other side. In this case, I need to subtract by 4. Okay, so I'm going to be left with x squared minus 12x equals 5. I take my b, which is negative 12 divided by 2, and square it. So that's negative 6 squared, which equals 36. So I'm going to add by 36 on both sides. So I have x squared minus 12x plus 36 equals 5 plus 36. So this ultimately becomes x squared minus 12x plus 36 equals 41. This factors down into being x minus 6 squared equals 41. And let me again go to the next slide really quick. So I have x minus 6 squared equals 41. So I need to square root both sides. And I get x minus 6 equals plus or minus the square root of 41. Now in order to solve for x by itself, I just need to add 6 onto both sides. So my solution is going to be x equals 6 plus or minus the square root of 41. Again, I'm not going to make it harder for myself if I don't have to. Okay? So those were two examples where my leading term was 1. Now let's try a couple where my leading term is not 1. I have 2x squared plus 8x minus 2 equals 0. In this case, I need to change my leading term of 2 to become a 1. I can look on my left-hand side and I see that everything is divisible by 2. So what I'm going to do is I'm going to divide the whole left side by 2 and the right side by 2. So 2x squared divided by 2 just gives me x squared. 8x divided by 2 gives me 4x. And negative 2 divided by 2 is negative 1 or minus 1. And 0 divided by 2 is still 0. So now my leading term is 1, and I can go ahead and complete the square just like I have been already. So what I'm going to do is I'm going to add by 1 on both sides, and I get x squared plus 4x equals 1. So now I have to do the b over 2 squared. So this turns out that I'm going to be adding 4 on both sides. So I get x squared plus 4x plus 4 equals 1 plus 4, or 5. So this breaks down, or this factors into being x plus 2 squared equals 5. And let me go on to the next slide here. I have x plus 2 squared equals 5. I need to take the square root of both sides here, and I get x plus 2 equals, let's make that a little bit better, equals plus or minus the square root of 5. Now in order to get 2 by itself, I have to subtract on both sides, and I get x equals negative 2 plus or minus the square root of 5. So not too terribly different and not too terribly difficult. The biggest challenge in this problem was trying to make my leading term become a 1. Okay. Now let's try one final example. Negative 3x squared minus 12x plus 9 equals 18. So again, my challenge is trying to take this a term of negative 3 and turn it into 1. But what I can see here is that all of my terms, each individually, are divisible by 3. So what I'm going to do is I'm going to divide everything by -3, both sides by -3. So I'm going to be left with -3x squared divided by -3x, or -3 gives me x squared. -12x divided by -3 gives me a positive 4x, because a negative divided by a negative gives me a positive. Positive 9 divided by -3 gives me a -3. Let's make that look better. It's a pretty bad 3, if I'm being honest. And 18 divided by -3 is -6, because a positive divided by a negative is a negative. So now my leading term is a 1, so I need to go ahead and take my constant and move it over to the other side. So I need to add by 3 on both sides. Got a lot of 3's going on. So I'm going to have x squared plus 4x equals -3. So now I take my b and divide it by 2 and square it. So I get, let's see, 2 squared, which is equal to 4. So again, I need to add 4 onto both sides. So I'm going to have x squared plus 4x plus 4 equals -3 plus 4. So this factors down into being x plus 2 squared equals 1. Okay, so let's take this to the next slide. So I'm going to have x plus 2 squared equals 1. Of course, I got to take the square root of both sides. So I'm going to have x plus 2. And in fact, the square root of 1 is actually just 1, plus or minus 1. So this is plus or minus 1. So now what I have to do is I need to get x by itself, and that means I need to subtract both sides by 2. So it's going to be x equals -2 plus 1, or x equals -2 minus 1. So x equals -1, or x equals -3. So there's 4 different examples of how you can go about completing the square along with some steps. So now what I need you to do is